Hey, Precalc students, going to give you a little extra tutorial here on working with parabolas, seeing as class didn't go so well. At least that's what Dayton Pie told me, so must have been a bad one today. Anyways, if we're going to graph parabolas and identify all these different important characteristics of parabolas, we got to be able to think a little bit. So referring back to the notes that we did today, at least in set 6, parabolas with a vertex at 0, 0 come in one of two formats. Either x squared is equal to 4 times p times y, or, and those would be the up or down parabolas that we're probably used to from quadratic functions at other times in math. The ones that will be slightly new will be where y is squared instead. So I got y squared is equal to 4 times p times x. Those are going to be parabolas that open to the right or to the left. Okay. That understanding, first and foremost, is super important. Where does my parabola go? Does it go up or down, or does it go left or right? Okay. The next thing would be to be able to find P, which again, people are struggling with this in class. P is the focal length. Okay. So maybe in the table that it didn't work out. The focal length is describing the distance between the vertex and the focus. Okay. So whatever that is P units. Okay, P for parabola if you want to think of it that way, but that's super important. That would be the focal length. That's going to determine so many things as far as our parabolas are concerned. It's going to help us find the focus. It's going to help us find the directrix. It's going to help us find the focal width. It's going to help us figure out which direction things are going, lots of stuff. So being able to identify which function am I working with and what's P. So examples. Number 3 straight off the worksheet. You might have been working on this in class today. If not, here we go. So I'm going to rewrite the two standard forms again for us to look at right here. Either we've got x squared equals 4 times p times y, or we have y squared equals 4 times p times x. Now again, recognize p is not going to show up. I don't see p anywhere here, but it's understood that it exists somewhere within this function. 4 times something equals the number that I see. I will see a y squared and an x, or an x squared and a y. But I'm not going to see p. I have to figure out what that number is. That's where a little bit of thought has to happen. So I notice that this equation that I'm supposed to work with has an x squared in it. I also notice that x squared is not by itself like it is here in the standard form that I got in red. So I'm going to do a little bit of algebra and get x squared by itself. So to undo the multiplication of negative 1/2, I could probably multiply by negative 2. If I multiply negative 2 times negative half, that's going to be 1. Now if I do something to one side, do the same to the other. So I now have an equation that would look like this instead. X squared is equal to negative 2 times y. Okay. Now if you need a minute to think about how in the world that works and why they're on the other side, and I did that, pause the video and think about it. You'll be okay. So there's my function. Now it looks like standard form. So which of the two standard forms does it look like? Does it look like the red one, or does it look like the green one? Is it x squared or is it y squared? Well, this one's x squared, so that means it must behave like the x squared parabolas do. Which, if it's x squared and y is not squared, that means that this is an up or down parabola. Okay? So up or down. Now my next question, if it is up or down, which one? Is the other side positive or negative? X squared, up or down, negative, ooh, that means it's going to go down. If this had been positive, we'd be going up. So that's the first thing I'm going to write over here. Which way does this open? This opens down. Okay. The next thing I'm going to figure out, what's P? What is the focal length? How far is it from the vertex to the focus? Well, if this is my standard form, x squared equals 4py, and I have x squared equals negative 2 times y, that means I have to do a little bit of thinking about how did I get negative 2 from that. 4 times p equals negative 2 somehow. Gee, what might p be? Well, if I do a little bit of algebra and divide both sides by 4, p equals negative 2 divided by 4, which of course would reduce to negative 1/2. Okay? That would be P, the focal length. I'm going to write that down over here. Negative 1/2. Okay? Next up, where's my vertex? Well, generally speaking, if it's x squared equals 4py or y squared equals 4px, our vertices, plural of vertex, will be at the origin, 0, 0. Okay. In later part of the lesson, we'll translate these parabolas and move their vertices elsewhere. So for now, they're at 0, 0. Just go with it. Okay. Now, to find the focus, which is the next important point I need to locate. Okay. The focus is p units away from the vertex. So here's where these two things, having the direction that it opens and p, the focal length, are very important. I'm going to go from the vertex down a half a unit. Okay. So from here, I'm going to go down 1/2. P is negative, negative meaning down 1/2. So I'm going to go down 1/2, and I'm going to put a dot at roughly that point right there. Okay, there's my focus. I'll pull F there for focus. Okay, this is vertex. I'll put a V for vertex right there. The focus is not on my parabola, but it's an important point that helps me draw my parabola. Okay, so labeling the coordinates of the focus. Okay, and here just takes a little bit of thought. What would be the XY coordinates that you would assign to that point right there? Could you refer to this table that I have right here that tells you, hey, if it's an x squared parabola, the focus is going to be at 0, p, whatever p happens to be? Of course you could. You can just plug stuff into a formula, and that's fine. Or with a little bit of thought, which I would encourage, I think you could figure this out. I know that my focus is at the point, let's see, I'm at 0 for x and I went down a half a unit. So 0 is still the x coordinate, but the y coordinate would be negative 1/2. That's where I am on the xy axis. Okay. Directrix. The directrix is a line perpendicular to the axis of symmetry. So my parabola opens down. Okay, it means my parabola is going to head this direction. Let's draw in a quick little sketch. That's my parabola eventually. Okay, my directrix is going to be perpendicular to the axis of symmetry. The axis of symmetry would cut the parabola in half, be something like this. That's the axis of symmetry. Okay, not the directrix. Here's the directrix, a horizontal line in this case, and it's going to be p units away from the vertex. Just going the other way. So this distance is also p, because all the points on my parabola are equidistant from the focus and the directrix. So if I went p units to get to the focus, I probably got to go p units the other direction to get to the directrix. So here we go. I went half a unit down to get to the focus. So that means I'm going to go half a unit up to get to the directrix. So half a unit up will be right about there. It's going to be a horizontal line then. That would be a half a unit above the vertex. So I'm going to try and draw a nice dashed line. It's not great, but that's the directrix. Okay. Now, labeling this. This is a horizontal line, and you need to write an equation. The directrix is not a number, it is an equation for a line. Okay? Horizontal lines will always be y equal to some value. Okay? Y is equal to whatever the y value of all the points on this line happen to be. Well, they happen to be 1/2. Check any point on this line, its y value is 1/2 regardless of what x is. Now again, if you're a formula person who needs to just plug stuff in and doesn't think a whole lot about it, well, here you go. Your directrix will be at y is equal to the opposite of p. P in this case, remember, was negative 1/2. So my directrix will be at y is equal to negative 1/2, or the opposite of negative 1/2, which guess what? Is positive 1/2. So again, little thought, or just follow formulas blindly. That's what our directrix is going to be. Okay. Last thing to figure out, a little bit tougher, the focal width. Well, formula-wise here, rule-wise here, we're told that the focal width, which is also referred to as the latus rectum, is equal to the absolute value, because it's a distance, so it's always positive, of 4 times p. P, again, is the focal length that we already found. So, if I know that p is negative 1/2, to find my focal width, I'm going to take 4 times negative 1/2. What I get when I take 4 times negative 1/2, well, that's going to be negative 2. But remember, this is referencing a distance. Therefore, I take the absolute value of -2, which gives me +2. That would be my focal width. Now, graphically speaking, we'll get rid of the parabola I started to sketch. I know that my focal width, meaning if I were to draw the width of the parabola at the focus level, okay? So here's the focus. If I were to draw the width of the parabola, the width would be 2. So from the focus, I'm going to go straight to the left 1 unit and straight to the right 1 unit. Those points are on my parabola. Then I'll just kind of estimate what my curve might look like. I'll draw as smooth as I can, which is not easy to do with a mouse, but you get the idea, I hope. You'll draw it better with a pen or pencil on your worksheet, okay? So that would be my focal width. This distance from there to there, if I drew a chord, connecting 2 points on a curve, a chord from this point to that point, its distance would be 2. It's perpendicular to the axis of symmetry. It's parallel to the directrix. It passes through the focus. That would be the focal width, okay? So those are all things that you'll have to identify as you work through problems like this. I'm going to pause there and come back and do this another example. We're going to do number 4 together as well to show you a left or right one, okay?